Good morning. I'm John Lincoln from the Photonics Leadership Group, and this presentation is about the current and future vision for photonics in the UK, and was first presented on the occasion of the 10th anniversary of Fraunhofer UK and the Fraunhofer Centre of Applied Photonics in Glasgow. So UK photonics is currently a £14.5 billion industry employing 76,500 people across the UK. Indeed, there are over 8 regions who employ more than 4,500 people in photonics in the UK, and the entire industry encompasses some 1,200 companies, all of whom are listed on our website and our directory at photonicsuk.org. And photonics includes a large number of companies working in the quantum industry. They don't have significant output at the moment, but we have high hopes that they will contribute significant growth in the future. So today, photonics contributes to the economy about £6.5 billion of gross value add. That equates to about £85,000 GVA per employee, and that's an indication of productivity. If you compare that to other sectors, photonics is already the 5th most productive manufacturing sector in the UK, 14th largest by overall output, and photonics employs 7 times more people than oil refinery. Topically, 2 times more people even than pharmaceutical manufacturing. And photonics is growing. We have aspirations to become a significantly larger industry, as I will show in our vision further on, based on our long-term growth. That growth has consistently been 4 to 5 times higher than the rest of UK manufacturing. Indeed, if you look over the last 10 years, we have grown from around a £10 billion industry to, in 2022, I forecast over £16 billion. So in the lifetime of Fraunhofer CAP, we have added £5 billion to the industry, grown by over 50%. And that is the basis of where we think we will be in the future. Looking at how we've consistently grown, not just in the last decade, but in the 2 decades before that, we see that we will become a much, much larger industry in the next 10 years or more as we compound that growth up into the future. So how does that compare to the rest of the world? Well, globally, photonics is around a €650 billion industry, or around $730 billion. And in Europe, it's about €100 billion, and the UK is the second largest photonics industry in Europe by output, next to Germany. And that $730 billion industry of photonics products is supported by around a $280 billion industry of photonics chips and components underneath it, and enables approximately a $2 trillion industry, according to the estimates from our good friends at SPIE, of enabled products. So this is where photonics is combined with electronics and software into, say, AR and VR headsets, so a higher level system, and that enabled products industry is very significant, partly because of the diversity of areas photonics is applied. If you look at enabled services, we don't put a number on that, in part because there is not a service in the world that is not enabled at some point by photonics, not least of all because the internet relies on photonics to make it function, and you can't deliver services these days without the internet. So we never put a number on that because essentially all services are enabled by photonics. But underneath that is a very significant market of enabled products, photonics products, 730 billion globally, and photonics components. So those numbers represent the history. That's where we are today and have been in the past. What about the future? Because the times they are certainly changing. We have seen in the last 2 years some incredible shifts in markets. So back in 2019, I produced a document that looked at the key priorities for many areas. But what we've done is seen these changes rapidly post-COVID. So whereas previously we were concerned about healthy aging, we're now very much more focused on health of all ages and catch up in our health systems. We've gone from looking at the timescale for fully autonomous transport systems to looking at the balance between home working and transport. We used to talk much more about data security and how we can leverage data. Now we see that being connected has become an essential utility, as vital as our water supply, especially to keep our economy running. So that's put a new focus on communications and indeed the supply of our communications equipment and networks. In defence and security, the Integrated Review in the UK has seen the addition of this focus on generation after next capability. So not just what can we do today, but what we can invest in science and innovation to give us a capability for the future. And partly around sustainability, we've seen a shift on focus around physical pollution from mitigation and waste and recycling to the circular economy, and how we can make sure things are reused rather than just recycled. But there are two areas we've seen some really dramatic shifts. So back in 2017, the UK Industrial Strategy talked about clean growth. By 2019, we had already seen that move on to a debate about climate change and localization of production, but localization of production because it was more efficient. Post-COVID, we've seen that move, if we think about COP26 just in November last year in Glasgow, to net zero targets. And we see huge growth in net zero and sustainability being integrated into corporate strategies across the world. Indeed, if you pick up most annual reports now, you will see almost as much weight given to corporate social responsibility reporting as you do to financial reporting. Simultaneously, coming out of COVID, we'd seen a much greater focus on national capability, where the origin of supply chains and where the origin of goods came from. But now, of course, we've seen another huge disruption in 2022, following the Ukraine conflict. Huge focus around energy. Energy costs have skyrocketed. That's causing a focus on energy efficiency, of course, and the source of our energy and the resilience of our economies. And I believe that in 2022 going forward, we'll see a combination here where net zero focuses very much more around energy, because there's essentially a double win there. If you focus on energy efficiency, of course you are better for achieving your net zero and environmental targets, but you also gives you more resilience in your energy supply. And of course, in all of these, we see a big shift in time horizons. These are not things that can be fixed in 1 or 2 years, but we see COP26 targets on net zero looking out 10 to 20 years in the future. And this is perhaps the most significant policy development in recent times, this shift of time horizons. So to fit that time horizon, we have developed a vision for photonics in the UK for 2035 that identifies 7 key areas where photonics will develop significantly in the next decade, including being essential to delivering a net zero economy, essential to delivering a secure and resilient nation, but also pushing the boundaries of scientific understanding. You don't get to do things like gravitational wave detection unless you have cutting-edge photonics, much of which, by the way, was developed in Scotland. So by 2035, we envisage UK photonics will be a £50 billion industry and add an extra 100,000 jobs, become one of the 3 most productive UK manufacturing sectors. And I have a lot of confidence in that because it's not based on one area. In fact, of these 7 areas, if one was not to occur, it would make very little difference to the growth of photonics. The strength is in our diversity, and it's that diversity that means I'm confident that that growth will be achieved. And to give you just an example, let's look at photonics and its impact in the energy economy. So 3 key areas we can impact energy. Of course, energy generation is the most obvious, and photovoltaics, we would be remiss if we didn't think about photovoltaics. They're improving efficiency, they're improving building integration as a key impact area for photonics. But that is not the only area. My good friends at Fraunhofer UK have shown that if you use LiDAR, laser-based detection of wind currents, you can improve the efficiency of our installed base of wind turbines. And if you do that by just 1 or 2%, you can generate enough additional power to save building 5 nuclear power stations globally in the next decade. And we can also have, and that's very significant. So there's a significant role not just in PV, but in improving the efficiency of renewables of other types, and actually even improving the efficiency of traditional, say, gas combustion through photonics. Then on the other side, energy use and productivity, we have many roles and diverse roles photonics plays. We mustn't forget lighting as a starting point. And if you do not have LED lighting at the moment installed, please go to B&Q and buy some LED lights. But in the future, we will see smart lighting, That's lighting that turns itself off when it's bright outside or adjusts itself in color to improve our health through circadian rhythm adjustments. But we will also see lighting used through Li-Fi to deliver data to us. Then in industry, we mustn't forget that lasers are essentially the initial Industry 4.0 tool, a fully digitally controlled system which can be used to cut, join, mark, finish, and indeed 3D print materials. And we will see lasers combined with machine vision increasingly used in smart manufacturing for more efficient production and more efficient use of materials, and an essential component in delivering e-vehicles and a more resilient, sustainable economy by offering efficient ways of manufacturing complex systems. And then, of course, there's communications and data processing. Data centers already use a significant percentage of global energy, yet we want to grow our digital economies at the same time as achieve net zero. That means a huge amount of innovation is required so we can deliver more capacity, lower latency, and lower energy consumption simultaneously. And within all these, we see net zero is really the true all-encompassing challenge of the 21st century, and some might think where photonics must and will have a significant role to play. To deliver that, of course, we need people. And one of the interesting challenges is the changing face of people supply, not just in the UK, but globally. We have, by latest reports, something like 17 million graduate vacancies in the UK and only 16 million graduates. This is across all fields, all types. There are at the moment more jobs than there are people. We are seeing a shift in the supply of people from a buyer's to a seller's market. I don't know if that's a long-term shift, and of course potentials of recession generated by current inflation pressures may change this, but it's very important to think how we maintain our supply of people in the future, because if we wish to add an extra 100,000 jobs, we need to make sure we know where they're coming from and we have a healthy pipeline of people coming in. And that's changing where we source our people, and many companies are already adjusting to the fact they need to be more proactive in how they reach out and find people to keep their growth on track. So I'm John Lincoln from the Photonics Leadership Group. We specialize in nudging industry, academia, support agencies and government together to make photonics bigger, faster, stronger. We never direct, all we can do is nudge. I'm very grateful to the support of all the companies who make a voluntary contribution to our activities. And right in the middle of that, you'll see the Fraunhofer Center of Applied Photonics, who we are very happy to work closely with and have been a strong supporter of the Photonics Leadership Group over their entire 10 years. Many thanks.